All right. So thanks everybody for joining again for the second session. And I really appreciate that you guys taking time from a busy schedule. Thanks for that. And and also I try to make sure that these 2 hours are really fruitful. We learn things. So that's what my intent is. And feel free to ask any questions during the session. I would like to make it as an interactive session, and and then we can hopefully we will learn a lot of things so that we can actually put things in our projects. So let me recap what we did last time, and then and then we will take it from there. So first session we spoke about Hadoop map reduce concepts. Then we did, and then we talked about Azure, how using HD inside.
Himanshu, we lost the voice again, man. There's some problem with the mic.
Yeah, I can't hear them.
Yeah. Himanshu, can you speak now? I just unmuted you from here. Can you speak something?
Yeah. Okay.
Yeah, we can hear you loud and clear now. Don't change anything now. Just
Yeah, sure. Yeah. So okay, so last time we spoke about SD Insight because that is where the big data clusters we can spin up using SD Insights here, and then you can spin up different clusters. So we spoke about basic architecture of Hadoop MapReduce. Then last time we covered about Spark, about we had a small demo about how to use Spark in an actual Azure cluster. We spin up those Spark jobs running on that cluster. Then we went to HBase. We created a table, and then at top of HBase, we Azure they provide Phoenix. So using Phoenix SQL line, we created tables and did queries on that. So basically today what I want to cover, it will be hands-on session, and feel free to ask any questions. So today from the big data stack, correct? So earlier we spoke about Hadoop, Spark, and HBase we covered. So today I plan to cover Hive and Kafka, and also we can have any more questions or related to it, and then we will look more into analytics part about what Azure provides for an analytics. So I will just give a brief about Hive. When we compare Hive and HBase and everything, so correct. So Hive is basically used for the batch analytics. So I just want to put here. So people might have a confusion about which technology to use if you are new to big data stacks. So HBase is there, Hive is there, Spark is there. So where does the Hive fit in, correct? So Hive usually is more for the batch analytics. It's a file-based sequential analytics you can have on not on a real-time data. Rather, you can have the data which is at rest. You put your files, and then you write your queries on those. So where Hive is basically, in a nutshell, it is more of a data warehouse for a big data warehouse where you just keep on data comes within your enterprise, correct? So when we talk about data warehouse, so we talk about data coming from different sources. So it's a warehouse. So data can be of any form, it can be of any source, and then you just dump your data, and then you do run your analytics on those, and then you have different tables and everything. So that's where the Hive fits in. Hive, Pig, they are kind of the technology for using for kind of batch analytics. So jumping more and like what is the difference between edge base? Correct. Edge base is again is like a SQL. Like you can have store your data in edge base as well. But edge base you can have you say like for example in a very simple terms. Correct. You have million records in a table, and if you want to get a particular product from edge base, you can do it. You can do it within an edge base. You can have a query where you get that product ID key and then you get it. So it's an O of one logarithmic time constant. And like with the Hive, you can't achieve that kind of like out of million records, you want to have one record. It will take a lot of time. That way, HBase is a lot faster. That's the difference.
Correlate this one kind of transaction systems, what we have like OLTP systems. No,
but again, that's a difference when you talk about that, correct? So there is still like a difference when you talk about transactions. You can roll back, correct? In an Oracle or like in an RDBMS system, you have a transactions you can roll back. But in this, I believe you can't have those kind of rollback mechanism. People are trying to achieve that, but still you can't have this.
So, but at the outset in the analogy, just
correct. Yeah, RDBMS, Oracle, or like you have tables from where you want to pick one record out of millions. It's a lot faster. Correct. Yeah. So with Edgebase you can do that, but with Hive you can't do that because it's a file base. I will explain and like do that. That is a one important difference. Second is like again like you spoke about transactions, correct? I believe they are trying to achieve with Hive transactions, but as of my knowledge, transactions are not possible in Hive to roll back or something goes wrong. You want to roll back your insights or that way. Okay, that is in a like introduction to Hive here. Hive also is an open source stack used in in like data warehouses. So basically, like if you're coming from a SQL background, correct? SQL or like as a database engineer. So if you know like SQLs, so it's like very easy to convert it. Like you can write your SQL queries on top of Hive, and like your queries will work pretty much. Of course, there is some differences there, but like still like if you have a good knowledge of SQL, writing SQL queries on like Oracle or SQL Server or MySQL, the transition to Hive is like easy that way. And like they're also trying to have more and more people who are familiar with data SQL queries. They want to support that. So one of the thing is like transactions, like they are trying to have that. Basically, what happens here, like in the first class, we spoke about SDFS here. Then we have Hadoop clusters here. Then we have, so now today we are talking about Hive, correct? So usually Hive, what we do day in, day out, we write this kind of queries. So if you look at it like from a like if you forget Hive, correct? If you look at this query, select zip code, I'm just giving some random thing. This is a standard SQL query, what we are having it. So you can run this query on top of Hive. So that's all. So if you are a developer, if you know queries, and like you are pretty much, you are a big data engineer on like Hive. And like the way Hive work is that like these are the queries, correct? So this is the queries. There's an engine like in an Hive world. There are like 2 or 3, like Hortonworks is there, Cloudera, big data stacks they provide. So it becomes a lot easier. So when you use these queries, correct, you need to optimize that. So like Cloudera provides their own SQL engine, because what happens is that you need to parse these queries, correct, and then it will go to your SDFS clusters, and then you do it. So Cloudera provides Impala, and like Hortonworks provides Trace, so that your query performance is a lot faster. At the end of the day, people are trying to get, like, I don't want, when I write a query, I don't want to sit for 15 minutes to get my answers to my questions correct. I want to do it in like as faster as possible. So people like Cloudera, they are working on Impala, which is more faster. There are different ways of making it faster, your queries. Similarly, for the Hortonworks, I believe they use Days for that to make your queries a lot faster.
So this is only for your data read. This is only for your data read.
Yeah. Hive is like how you can think of like you just dump your data. You just dump your data and then you write queries on top of that. So data usually, most of the time, like data usually will be a CSV separated files, comma separated files, or tab delimited. It will be structured data. So you have tables, and then tables are distributed across clusters. So because Hive is like kind of very, very important in the big data stack. Usually, like, uh, like Spark, that is also, Spark is a lot for real time and everything, but I believe like to get a meaningful insights from your big data, correct? From your data, which is huge coming in line. So Hive is the way to go. So like as a solution, like I would say depend on use case, but the Hive will be one of the de facto we should have it. Then if you have Spark or that is other way. So with Hive you can write queries and get your results very faster.
So each like vendor have their own set of high
Optimizations. Like say for example, you are using SQL Server, Microsoft SQL Server. So they will have their own optimizers working on that. Like it's kind of a parser, C++ parser. You have Golang that way. So it's like in a nutshell, large-scale data analysis to a broader audience, more productive than writing MapReduce or Spark directly. A few lines of high QL or like SQL will be equivalent to 200 lines of more of Java. This is so this is kind of an interesting statement, because when you at the end of the day when you write these queries, correct, select and everything or inserts, it becomes your MapReduce jobs. So if you don't write high queries and if you want to do this within your Java, of course there are people who want to go to lowest level and then like write your MapReduce jobs so that you have a fine tuning of whatever you want to do it. But at the Hive, it does the MapReduce jobs for you, mappers, reduces, and then it does that. But I mean, it's like lot easier. I will like show you. I have demos which will actually show you like how like then you really appreciate Hive instead of writing MapReduce jobs. I mean, like that way. And like also one more thing. So Hive also, once you have this Hive, correct? Hive provides connections to your like ODBC drivers are there, JDBC drivers are there. So you have your data, you write your Java programs, you can extract, you have your drivers, you can get information in your programs, in your Java programs or Python programs. So once you have the data, you can have some this kind of UI you can build up. So Tableau is there, Microsoft Power BI is there. You can connect with. I will just quickly give a difference between like kind of like comparing Hive and like Impara to a relational database. You can create different things. So if you look at this, correct? So like query language, relational database, SQL, you can fully support it. But Hive, of course, there will be subsets. That's all they try to do. Even for Phoenix, and that way will be there. If you look at the data size, correct, it's in like Hive provides like petabytes. Latency is very high. In a relational database, it's like very low. Transactions, like we spoke about transactions, correct? SQL, like any kind of SQL relational database will support transactions. So currently this, I believe it's no, but people are working on this side as well, on this transaction support for the Hive or for HBase. Delete individual records. With this is possible, but with Hive, you can't delete an individual record because it's a file based. I will show you that. Update individual records, again, is possible, but with Hive, you can't update individual records. It's a file base. You just dump your data and then it will create it. Yeah, index support. Of course, relational databases we all know has index support. Hive is there, index support is there, but they have this concept of partitions and like windows and bucketing. I will explain that. With that, you can have your indexes and like the way is like, but it's not like full fledged, that way. So this is kind of key. I will show you this. I'm just running through the slides very fast because I have got a lot of things to cover in like 2 hours. So whether it's your Hortonworks is there or like Cloudera or any kind of system, your SDFS files, when you create a table in Hive, it will reside usually in like user Hive warehouse. And this is your table is created here. If you have like create some table name will come as a directory in your SDFS. I will show you that. And then whatever the tables you created and then the files will reside in this. So you can assume this is all just directories. So your table name. This is any like important concept. So if you want to bulk load your tables, correct? So you just copy it to this directory, to this path, and then you upload your tables. Your say like you have a CSV file, you want to upload it, or like there are many ways. One of the way will be to directly copy those files, or like you have your insert statements and do it. But inserts on like million record or a million file, like you want to bulk load it, how you. So this is like kind of uh, like what happens here. This is like kind of an architecture point of view. So when you talk about the architecture of an Hive, correct? So when you install Hive, rather, correct? So you need actually Hive needs and Hive when you install Hive, Hive needs RDBMS. So even though it's a NoSQL or it's a big data SQL engine, it still depends on RDBMS. Why? Because I think by default it comes with SQLite. When you install it, it comes with SQLite, but you can configure it to any database, Oracle or something. So why Hive needs an RDBMS? So you have these tables, correct? Like data in SDFS files. You have SDFS. So you created these tables here. So you created these tables here, correct? These are all the directories in your SDFS, and under these directories you have files here. So, but to create these directories to meta store, which Hive or SDFS understands, correct? When you write a SQL query, select table. So all this metadata information is stored in these tables. This is kind of an important concept when you create tables. So when you write your queries, correct? So you write your queries, you have an engine here, then it looks out for the metadata for those tables, and then you get the actual data from your SDFS. So that's why Hive needs RDBMS database to store those metadata. Metadata, nothing but in a layman's language, it understands. It helps Hive engine to understand where the tables are, what the table names are, what is structure, the fields, and everything. So, all right, let me just. So this is. I just wanted to cover this, and like I would like to jump to the hands-on. So, so this morning, like in our first class, we went through of how we can spin up a cluster of similarly this morning I spun up the cluster so that we can save time in our sessions here. So what I did here is like I went here, data plus analytics, then you go SD Insight, then you write any cluster name, and then you configure your Hive here. And then you go through the same steps like what we did last time. So these are the same exact steps. I already done that because again spinning up cluster will take time. So So this is exactly the same. Once you go through those steps, correct? So you have this Hive. So you have this Hive cluster here. So you have this Hive. You have two head nodes, three worker nodes, and like three zookeeper. You can, of course, when you create your own cluster, you can change them. So once that cluster is up, correct? It's like probably takes about 15 minutes to come up. So again, you have SQL shell, yeah, and then you can log in with the same way. So I have done here. Let's so let me do it from here. So I have logged in here. Let me log out, and then we can again do it here. So I'm logging to this cluster. So once you spin up this cluster, correct? I would rather like appreciate if you could like do spin up cluster on your own and see. That will really, because all this hands-on will be helpful. So again, so it's like the same way how you register and create a cluster, do SSH. So here I am doing SSH to this Hive cluster. Password is P. So once you log in, you can type in Hive. This is the shell. So just note down if you want. That's what I'm doing it. Hive, Hive. So you log in, and then you have the shell. So yeah, so first thing is like, let's do show tables. So basically, like as we discussed earlier, correct? So like Hive, you day in day out you deal with these tables. So you create tables and then you populate this table. It's like any RDBMS tables you create. So there is a difference. Like RDBMS tables, they are different. I will show you that. But like that's how you create like. So we log into this shell. A few scripts here. Because I just want to drop all these tables first. So like the reason I'm showing you all this, because well, like it's like the same way how you deal with your tables, correct? Like any table. So this is just Hive, and like this drop table syntax is also like similar. So I will be dropping these tables quickly because I want to populate it. Probably I have a view somewhere. Yeah, I'll just take any table here. Yeah, so basically you write any queries and then you just drop the tables.
How does the backend text, like when you say it just delete the file?
Huh?
How does in the Hive backend works in this case? When you drop table, it will remove all those files.
Yeah, I will come to that. Because the way you create your tables is like different, like how you want to create it. Like internal tables and the external tables. Yeah.
Because of the
Which
When
one?
you try to draw Azure IDs, it's written as a view, right?
Yeah, no, somewhere I have created a view for that, so that's why. So probably that's a view I was trying to drop it.
That's a view.
Hmm?
Probably that's a view.
Yeah, yeah. The reason I'm doing it because I want to again do it again this one. Let's see how much this one. Those people who are familiar with queries, for them it's like kind of an easier way of. And also I will show you how from the UI also you can do things. Meanwhile, feel free to ask any questions, or we can share something. Okay, that's it. That's okay. So essentially, we don't have any tables here, correct? And like, so let me close this. So step one, you went to Azure, you spun up your Hive cluster. Then step two will be you go and do SSH, and like step three, if you want to look at certain things, correct? So using the UI, I will just show you the UI as well for the Hive, where from the UI you can write queries. You have Hive view here. So basically it's a simple view here where you can write your queries here. Let me show here some queries. Here, show tables. Yeah, you can do here. You can execute here. But honestly, like if you are like doing like kind of development, well, the command line is the much better way of doing it. Yeah, yeah, its option is there. Yeah, so like these are the tables. So when you first time create your Hive cluster, correct? So the default database name will be default, and like this is Hive sample tables. Azure will create for you. It will be already created for you. So I'm just giving you. Yeah, you can execute it.
Is Impala also available here?
No. Impala is for the Cloudera Hue. I think they have it. HUE. That's UI.
But it is not available in Azure.
I'm not aware of that. Probably they might. Cloudera might have Hue as well. So basically, this is you can do it on your like you can write queries here. This is a default one. So you can upload tables here from the CSV, but I will show you how to do it from the command line, which will what you most of the time we as a developer will be doing it. You can upload your files here, CSV, JSON, XML. So this is
We load from XML, correct? We load from XML. So we need to define those access define.
I don't know about XML. I have not worked on XML. I worked on only comma separated and tab separated XML.
Why ask you when you say ETL?
Yeah, comma. Yeah, might be there.
Not the JSON, but
Yeah, yeah. Okay, you have done that.
I have heard about JSON. So either you use parser and whatever data as it that's where you
are you using XML in our loading process?
So you have to convert it to some other form.
I think the data set we already there is a already transformation available. It's called stage.
Okay.
Available. It will take it but it will ask for access and those.
Yeah, schema for validation.
Define the parameters, what type of form it is and
Yeah. So this is the way, and then let's switch back to command line. Before that, I would like to just touch base with the Hive, like some of the key areas with the Hive. The rest you can like data type, integer, float, all those things that you can always go on. But some of the key things what I want to just highlight here. So this is what like basically the data structures, correct? Like it has standards int, varchar, and like all those things. Apart from that, it supports structures. Like I have highlighted this. I will show you this. Structures it supports. So like if you like structure is like a C struct, correct? You can have in compositions. You can have that. And then it supports an array. And I believe it supports map also. So these are the like and like kind of an data structures you will be like when you work with it, you can have much better control if you understand this.
And this could be same for all other instances, or like if you would have different data.
No, I think this is Hive. This is Hive. So the structures, then arrays, and then map. Then you can have it. So okay, so let's start creating a basic table. So what I do here, so if you look at the syntax, correct, what I'm doing is a standard query, create table, sales data, and then I give my columns, and then I'm inserting some records here. So let's do that.
Can we do employees because it is much better.
Yeah. I will do that. Yeah, I'm just going to do that. So like the way you are like if you're working, you take any notepad, you write your queries, and then you can just copy paste here. Of course, it takes like if you have queries, correct, HQL or something, there are command line where you can write and just directly execute as well. You don't have to copy paste it. Right? You have a bulk file, SQL, and then you load it. So yeah, it's a create table. I'm creating a sales data table here, a very basic table. So table created, select start from sales data. I'm doing it. So if you see, there are currently no records. So let's populate this. Let's run through this. Again, standard insert into table. These are the values. And here, like if people have worked on the Hive, correct? So there is some problem with this. If I do this one, is there anybody who have experienced this? So if I do this, correct, there is some problem with this. It will do this. It will insert it. So see, this is what I was talking about. Tez session. Tez is like kind of an engine which parses your queries. It's like doing map reduce. And then the records have been inserted. Let me do select all. So now you see this records, correct? Coming from this is what we populated. This is what we populated. So one quick question here. So just like I know people are awake, they are not sleeping. So like there's one problem with this. Anybody can think about that? What is the problem here? We created a table, we inserted something. I will show you the table syntax as well.
So data type, it does not.
Yeah, that is the thing. I will get my laptop charger.
What is the page? What is the page? We heard of that people spark or something but page. Someone like develop this page like this. So what is Tej? Like we heard of Spark and web.
Yeah, Tej is kind of an optimizer.
Okay.
So it comes with this one. Huh? Yeah, This is an engine which helps to optimize queries. So yeah, it's like as he told exactly. So the thing what happens here is that there is no validations. You can just dump any data. So when you write your queries, that time it will parser will get, and that time it will tell you. So that is the difference between when you have SQL. Yeah, you can insert anything. Huh? No, there is no validation as such, correct?
But there's no problem here, right?
No. There is no problem as such. I mean, problem in the sense like when you compare, correct? So there is no type as such. You can just have anything.
Already inserted.
Yeah.
Now when I'm trying to read, then it is parsing, then it is throwing an error. Like,
Yeah, correct.
Now what's the use of insertion? Like I know, I mean,
Now show the data, we can't delete it correctly. We can't delete the record, but what is the value? What needs to be done for it?
So we usually use varchar by default. Every column should be varchar.
So it's like you are allowed to dump everything.
Yeah.
but when you're reading, you're not allowed to read.
When you're reading, either you pass the data, clean it up as you want before you start doing your analytics.
Okay.
Yeah, that's why I wanted to press on this point. So
It lets you write anything. It will not fail when moving the files to a location. It's basically you are writing data onto HDFS, right? It will not let you stop you from doing that, but it will stop you from reading it. You're expecting something and that's not.
It will allow it. It will allow to load everything even in the non-risky character.
come again?
Non-risky character like the German word or any.
Yeah, I think it will. Because see, at the end of the day, it's like a meta store and it's a file based, so you can have that, correct? Yeah. Okay. So this is about like having a table here. So we added this. So to
So how
create,
does it, so you create like a other page job, correct?
yeah.
How does how does it determine whether it, when the backend is going to create a MapReduce or the Spark and based on like,
No, it will create MapReduce job. Spark is nothing to do with this.
what is it, then what page?
So this is for the this Azure Hortonworks provides like it's like optimizer for this. Yes.
So like you were seeing the number of mappers running here, right? So that all comes with page. It decides how many mappers to run.
So it will do optimization. So when you do joins, correct, inner joins or outer joins, that time it will have effect. So it's like having little bit you're better with this stage. They do this optimizations and like DAG and everything. So okay. So now let's create this. So I'm creating this kind of little bit complex table here. So here we have the structure, correct? And copy paste. So we have this. This is okay, but we are having structure here. So I'm like giving street, and I'm having a city. So that way, like I'm just giving an example, so that if you want to create a table with this kind of relationships, you can have this. And then you have an array where you can store this. So if you want to populate this, correct? So the way you can populate is like, I'll show you here, inserts. Let's first populate this. I always miss this. So again, it's like doing a MapReduce job for you. That's why, see, now you will appreciate. Now if you want to do it with Java, you can do it with Java also, pure Java program, mapper and reducer, and then it will take a lot of time. So assume, see, now the good part about Hive is that you can have your data size as much as you want, but you are just writing your queries, correct? That's the difference between big data. That's all. So here we have added this. So now what I'm trying to get here is just trying to get the first name.
So I was looking into this very good. The Apache page is extensible for framework for building high performance page and interactive this for Hortonworks.
Yeah, okay. Yeah. And for Impala, like Impala is for Cloudera. Yeah. Because they also see the way they make, they sell their products is like giving their own support and like optimizers for that. So
Also show how this data is.
yeah, I will show that. So here I'm doing this query, correct? Now if you look at this query, what I'm doing here, I'm getting this address.city, address.street and city from this where first name is this. So if you look at the structure of our query, correct, where we created, yeah. So I'm doing this structure here. So I'm going address dot street and address dot city. I'm coming here, correct? From employees where first name equals to some name. Yeah. So this is how you can do your like structures, and like now we have an array here, correct? So the same way you can get an array with this indexing. So what this query does is that it gets all the subordinate for this first name. This is the index here. So we have this is an array. Variable is subordinates. So when I insert it, correct? So I'm inserting it this as an array. So for this person, Vishal, we have the subordinates, and I'm trying to get this multi query. So another way is like if you the size is there. I'm just giving some examples. Like SQL can be very fast. So these some of the things which helps in that. So here it will give size, array length, size of an array. If you want to have map, so map here I'm creating with some name. Give the size of that map. Map is key value. So this is the map you have, name and age. So there is no structure. You can just put it any map and then you can get it. So this is also I'm giving some of the examples. Like explode is there, where it will retrieve all the. It will give all the. Any guess about this query? What it will return? This one. If I do this, so we at the top we have this inserts, and I'm writing this select explode. I just want to highlight on explode. That's why. The first name is Vishal. What happens is like basically it gives all the subordinates for that one explode. So you have this one coming out. So this is an example of how you can write your queries. Correct. You don't have to be when you deal with this big data thing. Correct. You have the difference. The reason I highlighted this because you can have primary, foreign keys, and one to many, many to many, and all those things. With this, you can have the same thing. You create one table, and then you can do this. Correct. So here you have earlier you have probably in your school days we'll be doing one to many. Correct, for this one, and then this way if you do it, it's a lot faster. Correct. You don't do joins, and because joins are always slow. So this way you just have it, and then you can populate that. So there is another concept of lateral view. Because this you will be using it if you want to use it, you can use it in your JSON and your XML schemas. Because most of the time it's like usually the JSON is like you have parent, then you have tree, and then you have root, and then you have tree. So you see what is the difference between the earlier query and like this query? Earlier query I had this. Yeah, so I had this. I think. here. So here we are having explode, just explode. So it returns what are the contents of that array. So I have this first name and it returns contents of this array. This is the same thing. But when I do this lateral view, so essentially the only difference is that I get the parent also with this. So earlier I just got this, but if you have your logic correct, you want to extract, you create a report where you want to have want to show this, so you can extract that and then. So let me create this table. Because I want to show you the structure as well. The table already exists, looks like. Let's see. Yeah, so we already have the data. Let's move and drop it. This. Yeah, before we dive more into this, correct? Let me show you. Now we have created like enough tables, correct? So now, if you want to figure out where is the location of those tables, where are these tables created? So the way you do is that you have to go to yeah. So I will just like if you are doing it correct, even for the AWS or even for this, there is a set path for this. So like in one of the slides where I mentioned about the path, correct? This is the path where all the tables are, where the tables are stored. So that's where the path is like that. Let me log into Hive first, so that we know what are tables created here. Come up before it comes. Usually in this, in Azure, the path is this. So you would be executing this command as dfs -lsr and then Hive and warehouse. That's where all the directories are created here. Slow. So I'm just showing where the directory path will be. So these are the tables we created, correct? And now sales data and the samples and everything. So So these are the actually you should do if you want to really look at the directory structure, correct? You should do this something this way. This is the root directory of SDFS. I should not do this. So these are all the root directories. So when your cluster comes up, these are the folders it will create. One is the /user /hive /hbase /apps. So for if I do this correct /hive ls. So this is where the folder is created here. This is the default one. So any table you create, it will be residing here. If you look at the slides here, so this is what will be here. Of course, I believe you can change it in some XML file. So let's go one more level inside this. So now you see here, correct? So these are the tables we created. So all the tables, they are all the directories here. So these are all the directories. And then inside this is all the data we have here. So it's sales data. If you do this, should be fine. If I do this, if you want to see the contents, correct? Probably this one. I think this is the output of the file.
So you say we have understood table name.
Yeah, these are the jobs. Yeah, these are the jobs. What is data here. So these are the data what we ran here on these tables. So if I do this correct. I think this is the directory. Look at this. This is going to files.
So this underscore 005. So means if we do any operation, those version would be updated, like the version 01, 02.
No, I will show you that what is that. What is that? So like so far you guys are with me, correct? With this. So like you have the tables created, you have the directories created, and like inside directories you have those files here, correct? So now earlier you were asking, correct? Like if I delete the table, what happens? Correct? So yeah, so there is two concepts there. So when you create a table, correct? Earlier we did create table here. So let me show you here. This is what I just wanted to go some more deeper here. Yeah, I will come to your. I will answer that. I just want to go through that because then the context will be proper. So far you guys are with me, correct? We have this. This is what you will be doing it, and then so now let's move on, correct? So now you want to populate these tables in a bulk, not with small queries, inserts, and something. So usually most of the time you'll be having files where you want to dump it, correct? So like I think in your work also, like what you do here, I just want to show you that earlier what I did. Oh, sorry. So earlier what I did, I created this directory. This is some data sets, ML 100K. Usually you get it from here. So just to play around with this, correct? This is a very movie lens. If you want to play around with the data sets, these are good data sets. It has got huge files. So like 20 million records are there. So what I did, I downloaded this record sets, 100K data set, so that we can work on this, create tables, populate this. So I downloaded this, and then from this site, this one. Yeah, clients, you go there. So you get, there are many data sets available. Many. So I just downloaded one of data sets here, and then using FTP, I uploaded my data. So the data is populated here. So I created directory, and if you go inside this, you see the records here. So these are some of the data here. If I do cat, I will show you which we are working with. You can just so essentially, just like kind of a movie ID is there, and some movie name, and then some kind of ratings and like all those things are there. Yeah. So if you look at this, they have this. We are working with this u.item. If you look at it, this is the columns they have: movie ID, title, release date. Similarly, like most of the data sets will have some kind of structure, product ID, features, all those things. Yeah. So this is the schema for this: movie ID, movie title, release date, and like all those. And then there are different data sets. This is one, and then you have u.data. So I just want to show you this, how we can populate this. So now I will create this table. This is based on the data set what we just seen here, correct? I will again show you, right? But let me just create this table, and then I will explain what we are doing here. So I'm doing copy paste. In your work also, you will be doing something like that. So create table if not exists. This is the table name I am putting it here. This is some ID will be there. So I'm just explaining because we will be working 5:15. Okay, I'm just going to, we will be working on the queries here. So movie ID, title, release date, and like these are the different things here. So if you look at this, correct? Once I have a bracket, I have a comment here. You can, when you create a table, you can create comment here. This is more of high specific. Row format delimited. Fields terminated by pipe. I'm doing it here. So like the data what we had was terminated by pipe. Either you will be having pipe or comma or like whatever you can have it. So you have to put it there. Lines terminated by /n and stored as text file. So I'm creating this table. The table is created. Let's see, select star from this table. So currently this one is empty. We don't have any records. So now our goal is we have the files from our desktop. We upload it to the server, to the cluster. We want to populate our like we created a table. Now we want to populate it. So you do here this one, load data local in path. This is my path where you have this file. So when I create this table, correct, that's where the things comes in, like overwrite into table. I'm doing it here. So when you create table, there is concept of internal tables and there's concept of external tables. So that's where, like when you delete a table, so all this, when we are creating these tables, correct, these tables and everything is managed by Hive. So Hive will take care of that. So you won't lose the data. And then if you don't want Hive to take care of those tables, you can have external table. Create external table, and then you can give the path. So here I'm populating it. This is the path what we have here. So from my home folder, I have this data, and I will populate these tables here. This table. This is loading data into table. Now, if you see, it's so fast, correct? 0.978 seconds it took to populate, and then like it's a decent size record. If you do this, correct? So now I'm doing select all. So it's like, and like this is what it's populated in our table here. So now we have a table we have already populated. Let me create one more table, and so I have created a view here. Let me go into more tables. So now I'm just showing you some of the queries what you can write. Your standard SQL queries, you can write it on this table here. So I'm doing here select count, and I want to find the animation movies as animation, like all the movies which are like classified as animated, like animation, and like group by I'm doing it. So here where your mapper and reducer, your Tej engine comes in picture. So the more joints you have, how you optimize this, correct? So I'm getting this record here, 42. This is some more queries here.
Is there a way that we can estimate the number of shootable based file sizes?
Based on the
File sizes, we know how big is the file actually is.
correct.
So there can be an estimate how can
Like, theoretically, you should be able to do it. I have not done that, but I don't know. But theoretically, definitely, you should be able to do it.
Because what I see is like when you do some songs or something, you see so many users. So that
So you can always control it, I think.
yeah, but
like,
what is the right way
yeah, I
of
don't know.
controlling?
Yeah, right way. Even for the Spark jobs, like I have looked at some videos where they say what is the right way, correct performance tuning. They say there is some of the tips they give, but it's not a full fledged, like a hardcore. Oh, this is the thumbnail rule. This is the way if you do it. You will get it. You can optimize. It's like how in a SQL query also, like you have like yeah.
I can optimize, but I should know okay things when you use that I should be able to estimate. Right?
Yeah, that yeah. I don't know how. So I'm just showing you some of the queries where you can like what you do. So here the reason I'm showing you these queries because if you the same thing you can do it in okay, this table is not the let's create it. Because the same thing you can do it in Spark, correct? Same thing you can do it in Spark. So which one you will choose, Hive or Spark, or like you will write MapReduce?
SQL, so I write in SQL.
Yeah,
Depends on the
that's
skill.
it actually depends. So yeah, but like I think you should have both solutions. Honestly speaking, it's not a diplomatic answer, but it's a safe answer because Hive you can always go back and write your queries and figure it out immediately. With the Spark, the time to debug will be a little more. That's what will be correct. So if you have both the systems, probably you are better off. Correct.
So mostly we keep the data into Spark, like memory, right? So if we have a huge database, huge data sets, so we should go for Spark or we should go for Hive?
No, Hive and Spark. I think the difference will be your use case. For the huge data set, I don't think it will make any difference, right? Because the Spark and Hive will do the job. Like if you want to do it faster, like Spark. If you want to do analytics like in a streaming way, then go for Spark. This is more of a batch mode. You are writing queries here, right? And yeah, because Spark will also handle the same. It's a huge file, right? So it will create. You have to create that many workers and all that. Similarly, this is also doing the map reduces. But here you are putting it in a file, correct? The IO6 is happening here. Yeah, but in the Spark, you don't do it in a like in a file. You do it in a memory. And Spark was DAG and RDD concepts and everything. But here nothing as such. Yeah. But I think this is more like a faster way of doing it. When the Spark, you write queries a little bit.
Development time and all.
Huh?
Development time
is more with the Spark. Like if you want to troubleshoot something, probably it will be.
persist data.
Huh?
You have to persist data not to understand Spark, right?
Yeah. I'm not able to, honestly, tell you go with Spark or go with Hive. We are just doing it. But I think both the solutions you should have it. Like if you want to have it becomes easier. That's what I feel. Yeah. Okay. Let's create this table. Is not there. I think table we missed out. Yeah. There's so many windows open. Yeah.
So like we say that Spark is in memory. So initially it brings everything into memory from disk or how it works. Like it works as a memory model. So everything is on disk and it brings everything into memory and then starts working on it. How is the initial load? Okay, I started this server. I started the cluster. I mean, it goes down and I started. Now what happens?
Yeah.
Will it be slow in the initial
You code it so that you have a table.
Yeah.
So you have to write a command to move it, load it into memory. You have to create RDBs, data sets in memory. And then you play around with those data sets. So everything, whatever you write, every execution happens in memory. But you have to load the data, you have to write those statements.
Okay, let's create this table. So I'm creating this table. This is not there. So again, I'm creating the same way. This is the ratings. It's like a movie ratings. How many users have rated a particular movie? So you have this rating count of these movies here. So we have this user ID. So essentially, like even in your projects, I believe some of things will be the same. User ID will be there. Some IDs will be there. Products ID will be there. And then you map it and then you do it. So here, fields terminated by /t, tab delimited, this one. So that's text file. Creating this table. Again, I'm populating this. I will show you the data here. So again, we are doing it load data locally in path from my home directory I'm populating with, you can have u dot data, you can have CSV, you can have anything. It just like when you create your tables, it should understand this. Yeah, so basically our table is populated with these ratings. This is some user ID, I believe. Yeah, user ID, movie ID, and then this is the rating. User ID, movie ID. This is the rating from 1 to 5, and this is, I think, timestamp. Let's have some going along. So I can create a view as well. In case like people are curious what all we can do with this. I think this view already exists. Let's create another one. View is created. Let's query on the view as well. Now this is just like, okay, we can, I think that view is created. I'm just showing you some of the queries quickly. This is getting it from the view here. So the same average, your aggregate functions, average, max, min, all those things, you can have it. So you got this data. So this is a lot faster, I feel, compared to a little bit, like easier to work on the things. Again, there are some more queries on this. Yeah, one thing I just wanted to show you is like yeah, this one. So you are in Hive, correct? This will be a little helpful if you are working on this. So you are in Hive shell here. So if you are on command line, correct? Now if you want to store this output to a file, how do you do that? Well, most of the time you want to share your outcome. You can't do copy paste the whole thing and send it. So you want to dump this output to a file. So one of the way you can do is with this. Yeah, so what you do here, you are in the shell, correct? You do hive -e, and then you can write your query. You write your query here, where whatever the query is there, and then you can output, and then the output will be created. I already have it. Okay. So your output result will be in this file. So it's like easier, you can share it. Yeah, it's in here. Home, SSH user. This is our home directory. I'll show you. Because you write queries, correct? And the output you want to share with somebody, correct? This is what your mappers are, reducers. And if I do ls, this is what the output is created. New one. Let's do that here.
So looking at the backend, can identify that okay, block in case it will be long. Can identify
I don't know. I have not done so deep dive on
Transaction for now we are reading the data, but again it's trying to.
No, this is not for transactions. This is pure analytics.
But still, like I have to use someone again from other team, someone is pushing the data into this table.
We'll let you do it.
Huh?
We'll let you
You're not doing- you're not doing it. There is no locking mechanism like table is locked for reading or no table is say have file based.
It's a file based. It's just like your meta store will have this.
30 weeks of means basically anyone can write, even there's no law.
These are transaction table. Maybe in future they may be correct.
Yeah. They are coming up with transactions.
But again, that is slow. Huge volume transactions.
At least they can provide a log. Maybe I'm reading data, I can log the file.
Yeah, means there in big data you see more flexibility is there to do something. That's why they let you do everything. Like it's like you monitor the computer, like desktop. You can write a file. Until as you do something with that, it lets you go. Even like in our project, it's CR project, there was a time when there was, so what they do, they drop and recreate the table, extensive tables. Like we have files, but we drop and recreate the table.
So like dropping the file sets.
The files are there, so like it's external, right? So data is already there. You just drop and recreate the table pointing to a newer file. Okay. And in that time, somebody else is accessing the table, but there is no way you can log. So there was a problem that one was still looking for it. There was some logging on this waiting for this one. So there was a deadlock situation. But they said that you have to give priority to something.
I think because of the in that case, how do they think? The one the user who is a high privilege, you get more.
That time we involved in infra saying that this is a deadlock. So they killed one query. Then it released the log and another process completed.
What they build the law. So as you said, now what is that read law? I mean,
I don't know what kind of, because that was a table change. That was a DDL change actually. It was not a read log or something. It was DDL change.
so if someone is selecting and the dividend, it might possible. So what is not again? So in like traditional sample data, what they have provided, they basically categorize the user, high priority user. So high priority user start working to pay random security application as a secret thing. So now the resource will go, other will be hold on.
Okay, it's kind of queuing mechanism.
Doing mechanism, but will be prioritized. So is there something like in here also?
Yeah. There is some like there are multiple users.
Sorry, there are multiple users.
Batch processing, like how much resources you want to allocate to this user, they do that. They do that. So that's about running the query. You are running heavy queries, so that they will get more resources like that. But not user not access like okay, you have drop permission, you don't have drop permission. Those kind of things are not there. But it's there again.
But like suppose I am admin and I want to run some query. It's like I have some like batch process, which is batch user, which is a high priority production job runs. And if some like one query and run very high intensive query, then
They will.
Yeah, there will be. Yeah.
But Himanshu, is there a possibility that like we can give access to a directory? I mean,
Yeah, I believe security is there.
okay.
Security is
Suppose,
there.
if I give permission to someone on the directory in the system, so that they can only change and pull and push data. Others cannot go and modify files. Is it possible?
Yeah,
I
it
have
should
not
be
seen
there.
individual level access. Means they give a pseudo user they create, and the user has the access to do so. Using that pseudo user, you can do that. But individually, they are not given that.
I think it's the same like a schema level access, right?
Yeah, you can say.
So like because over here the directory is schema, and then within that like it's any file is being created that is a table.
Yes. Individual user access also means you can create a database of your own on Hive, and then you can play around with that. That is also possible, but they don't give it. Otherwise, everybody will create their own database.
Yeah. All right. So basically on the UI part, correct? So it all the tables what we created are shown here. So if you want to play with the UI, you can work with the UI as such. So I would like to if there are no questions or as such, I would like to move to Kafka. Like, basically, these are the key, like to summarize.
There one question which I asked
Yes.
is how basically internal the table data is structured in the file. It's like one.
Yeah. Sorry, 3 or 4. Yeah, internal.
Like how much data is stored in the HDFS?
Yeah, it's a file. It's a file.
But like suppose we have like 10,000 records. Like how those are linked together? Anything like
Yeah. I have to do that. I'll show you. So there's a concept called partitions here.
Okay.
Yeah. So
they build one partition per file. One partition. One file partition.
No. So I will I will explain what is partition.
Must
just for that
file
thing.
size, I think.
Yeah. Let me do it. So we hand this.
Is it recording or not?
Yeah, it's a recording is there. So yeah, so now here, like as he was asking, correct? So in a real world scenario, you have 10 million records. So if you run this, correct? So how do you optimize that, correct? So like basically we have directories and we had just one file for the small things. It will create one file and then do it. And then we want to optimize your queries. So like in the indexing world, like we have indexes and then we do it, correct? Similarly, here we have concept of partition. Partition in the sense like you have the directory here, correct? Let's do it here. So here, when we created, let me just give here quickly. I want to switch here. So here, like all these tables we created, correct? Mm-hmm. And then we have the records inside this, correct? So now this is the plain tables what we created here, and yeah. So now there's a concept in Hive. There is a concept. There are like actually 3 concepts are there, important things. One is the partition, other is the bucketing, and one more thing, it's like window function. Window functions are there. You understand window functioning, correct? Window functions.
Window function, right?
Yeah, it's like do summation of that from.
Yeah, it's
Huh? Yeah, so like windowing is like suppose you have this sales data. I will just show you here. So you have this data, correct? Like you want to sum, like you have a record. Forget about basic, like 100, 200, 300, 400. 100 plus 200 is 300. 300 plus the next row is like you want to add.
Okay.
Yeah, add cumulative and cumulative and like probably you want to get it like top like row or like those range kind of things. Mm-hmm. So earlier we created this table, correct? Sales data. So here is a concept of partition. Partition by order date. I'm doing it here. Let me first show you the sales table here.
So partition is compulsory.
No, it's not compulsory. If you want to optimize it, so earlier we created this table, like sales data. Now in that we inserted these values, insert into sales data and like all those values. So now if you want to partition this, correct? So partition in the sense like you are partitioning based on based on a use case. So there is kind of an indexing. So it will create subdirectories. That's what the answer to your question is. So it will create subdirectories, and based on the more partitions, So in a nutshell, like partition is nothing but simpler. In your directory structure, you have one directory, you have inner directory. In the inner directory, you have one more directory. So based on your partitions, you can partition that way you want, and your data will be residing based on your partitions. Say for example, country has got states has, so country is your main parent directory. Then you have a directory as states, and from the states again you have a subdirectory called cities, and cities, for that particular city you have some data. So that way you can structure it, and then when you query it, you will be querying based on that subset. That will be a lot faster.
But we may not like if you do which is not partition, the field which is not in partition. Suppose I do I have first name, last name, birthday.
No, you have to do, otherwise I think I will throw an error.
So when you say partition,
No, like
define hierarchy.
huh?
You say like when we are defining the partition, we need to define some sort of hierarchy. Like as you said, like
No, of course. See, when you do partition, like you have your business case, correct? Then only you will. Okay, first of all, why you are doing partition?
So actually, when you create a partition, you have in relational database, right? Like you have 4 columns on which you partition. Compose it here or something. So
there is use case with that.
It creates a directory structure on file system. So you have for first level of partition, after that another folder, another folder. So ultimately your data related to that particular combination is set at this point based on the partition.
So in answer to your question, I think if they're not using partition, definitely the query performance won't be optimized.
No, it depends. So I believe your question was how data is distributed.
Yeah, correct.
So that's
Yeah, it will be subdirectories. Yeah, it will be subdirectories.
I'm asking for understanding purpose.
Yeah.
No, it will be suppose you define the partition, I agree. If partition produce partition test, no issue. You know that code what I
Correct.
But suppose if they is taking data from that partition, which is field other than that partition. So will it allow it or not?
It will allow it to go for full tables.
So the thing is, whatever partition you define, you need to define it in your query.
Yes, you have
You have to do it.
There are statistics again you can connect. The files are distributed in the cells by size 128 MB. If file is greater than 128 MB, then it will split it accordingly.
Then
distribute from the system. Otherwise, it will always sit on one.
Yeah. So now just showing you the partitions here. So let me just run this query.
We understand very well. They are very good concept.
Yeah, partition bucketing is kind of a same. Yeah. So like say we have this data, correct? So like I did select star from sales data. So we have this data. So now we want to partition based on some logic, probably where the cities or like place or like based on some. So when you do partition, in nutshell, what happens? It will create a directory inside that. Yeah.
Suppose if you want any partition, then how do you
It's like
No, probably it won't.
it's by file size.
It's
So
file
it's
size.
never by three columns. Because file you never know what your data is like. You don't know. Error data you know what all is like. So here it's like size.
Yeah. So I'm just creating partition here on the same table, but I'm creating a partition. So now if you look at the structure here, correct? What I'm doing here, we have product and revenue, and I'm doing partition by order date. So that way, when you query it based on your date, order date. That will be a lot faster. You have whole month. You don't want to get the whole.
In this case, if you have 20 million or 50 million dollars, say like 5 years of time, each day you have to then it's like 5 years, 5 so many files.
Yeah.
Okay.
Yeah. So now I have created a partition here. Correct. Create table, and like earlier we had store location product, and like I'm doing it partition by, and I believe is that this order date and like partition by order date, it should be the last column in your when you create it.
So you know when you create a partition, you note that column because it will be the file name.
Yeah, it will be. Yeah, it will be that kind of. I'll show you here. So and then when you insert it, you insert based on the records here partition. And then there is concept of dynamic partitions, the strict and this. I can explain that. So here I'm inserting records into that partition. We have created it. Let's try to query it.
So I don't know that partition has been created on the table. Still, I can use.
No, you will be able to know that.
No, basically,
No, so there is a I think there is when you describe table, correct? Describe. So like if you want to get the schema of a table, there's a command called describe, and then extended you can have it. Describe extended, and I think table name. So like this one will tell you what type of table is. Is it internal table or it will give you the metadata for that table. So this one will tell you like what a table is, where it is stored. So in our case, it's in like the data, metadata, partition keys, location of the tables in an SDFS, sales data. This is the path. This is the SDFS path. So we have created table, correct, and inserted. So now let's look at the structure here. So now it has created this directories here based on your date. Yeah, these are the two directories. This is how the partitions are created. I think if I do this, yeah, you can see that. You can see, so you can go inside this and see what is the data here. Now if you do cat, you should be able to get records only for that partition. So that's why I feel do you have more control on your data when you're working with Hive? I don't know. Oh, okay. So you get kind of filtered record. So this way you can have as many directories, subdirectories you want. No, of course it will become the more partition, the more files are created.
information for name node. That's
Yes,
where again
true.
there were problems. They were saying that too much of information,
Yeah, too much partition.
too many of
Right.
files is again overhead for
Yeah, this is one of the like if you're working with Hive, correct? Performance tips. This is one of the things what to take care of. You should not have even for the Spark also. Like even in Spark world, you can have partitions. So more partitions sometimes is a problem. Less partitions also is a problem. So you have to do it in a way based on optimization. It's like trial and error. Honestly speaking.
yeah, trial and error, but it's more problem comes with huge volume.
Yeah, of course.
Then later when you say, oh, this is not partitioned well, then when you come back and revisit that, then it's too late to do anything because you have written huge data already on HDFS. Then you want to repartition that huge data again.
Nah, yeah,
It's
it
not
will
that
be.
easy. So it's critical.
Same thing happens in Teradata, that is also distribution care.
Yes,
Unique
but
index.
it's, yeah, but you can easily move the data. Here you have to clean the files, you have to do everything again. It's more manual work here. That is more tough here than relational database where it is easy. Any restatement and all over here is like too heavy.
Lot of labor.
Yeah, lot of labor.
Yes, my VPN got reset. Let's see.
So the same thing, like if you're showing the 5 years of data and the partition is on the data, like minutes,
That's what means by question. Like,
not even the order type.
files.
The other thing you see that here is that you are, if you say, okay, order, like 1 month of data has normal, right? So you have a specific way of cleaning that 1 month of data here because you have partition by order. That is a benefit you can see here. You remove those files, you load those files again. But if it is non-partition, suppose it is non-partition.
If it is non-partition, then it's really
it's bigger headache.
it's bigger headache.
You have to clean the
And
entire
data
file.
file.
You don't know where the record is.
Right.
That also comes into picture when you partition. So just in our like in Gap as we have implemented various things, like all the dimension tables are non-partition. All the fact tables are partition. As same as relational tables. Same way.
Let me try to execute this.
What is the height? The second dimension.
So the way we are like refreshing the partitions in Teradata, do we require to refresh the partition? Refresh partitions. So let's say like the partition is defined. Mostly if you see the table definition, the partition if you define on the
there is a dynamic partition.
Okay.
So based on data, it will figure it out.
Okay.
Yeah.
It will create the partition.
Which partition typically they recommend?
Yeah, dynamic. Yeah.
Because you don't know what kind of data is coming. So regular, you can't sit and define that.
Yeah, you can define the.
Like the one which is non-coded, there is a hard coded, right? Order date equal to this. You can't do that. Regular.
But ultimately in dynamic also they will take orders from it.
Yeah.
Find out that
Yeah, so the Hive does
distinct value and
Hive does it. It based on it sees, okay, this is data point, this is a direct partition in B, and I have a value for this, it will create a direct partition. No manual work there.
All right. So, yeah, actually, I wanted to do it Kafka time check. I had to hard stop at 6.
It's almost 6 o'clock. Himanshu, do you want to?
I will just summarize so that I think is there. And also, like earlier, I showed you like quick tips here. Yeah. Okay. All right. So earlier I showed you about this, correct? From your terminal, if you want to execute high queries and like have the output, this is what you will be doing it. So you execute. We executed this command. Okay, let me see. I just wanted to highlight this because you like if you are working on the things, correct?
So to Hive from some reporting tool or I mean SQL queries from there.
Come again? What?
Huh?
So can you hide from different recording tools?
Yeah, yeah. You can do it. You know, like even the UI, correct? I believe the UI, the Ambari probably doing it some.
It's not that fast as
Command line is best.
yeah. Even from reporting tool, when they get it, again result doesn't come that fast because again these are big queries. Microsoft. So they tried connecting directly to Hadoop system. But it was not giving them results properly. So now the design is you do everything on Hadoop, shift parallel, and that's
That is it for specific for?
no, it's the design level because MicroStrategy connecting to Hadoop server is not that.
The problem with the MicroStrategy.
Yeah. So as of now, most of the reporting tools are not that effective with the Hadoop system.
Yeah.
I read that Power BI it does have.
Yeah, so these are the new things coming. But existing reporting tools are not that.
Yeah, I guess the command line queries is
Yeah,
like
those are
this other.
I think Teradata's is an assistant we are using. That is also good. But
Yeah.
command line is the best.
Yeah, command line is the best because those are the toad and all those things. Yeah. So basically before we wrap up, I just want to show you. So if you are in the bash, you want to execute and like save it and output, we can do it this way, correct? Like we did it this way. So other way around, the reason is that if you want to write your shell scripts or send email or something you want to do it, you can do it is like the other way is like you are in Hive and you want to execute some Hadoop commands. So you can do it this way as well. So if I go to Hive, anyway, this file is created here. It's already there. So this is the output. This you can like send it to anybody and like be done with it. So the next thing is if you are in Hive, correct, and you want to execute, you don't want to shift your shell and everything. So inside Hive, you can execute your Hadoop commands. Here, like people are a little aware of Scoop and Flume, correct? A little bit. At least they know what it is. Difference.
Yeah.
Very high level.
Yeah, high level. Okay, that's fine. So with Hive, you can have your internal Hadoop commands here. You can do it easier. You don't want to. Yeah, any command. Yeah, any Linux command. So, yeah. So that's all. So I just wanted to cover Kafka, but not today. Then I have like. Did you guys? Okay. Now is the.
What is it they're getting? The more cheap, scalability. Two things. But the skill set is not one.
No, you are not looking for performance. If you're looking for performance,
it was supposed to be 1.2.
yeah, but huge volume processing in relational databases. So that's where this comes.
All right. Time check here quickly. Anybody did any assignments? Gulle sent. Gulle?
No.
Okay. All right. Okay.
Did not even get this. Where did you get the link?
Huh?
Where did you get the initial
I don't.
last week's ready recording? Did not.
No, I think Gulle has sent it. I don't know.
I uploaded.
So anyway, so basically, I just want to just do it. Solutions are also there.
Hello, can you
So
guys
these are
hear me?
the assignments. Like if you want to try, with this basic playing with Hadoop.
Hello?
I don't know.
Hello, is there? Hello?
Himanshu, can you hear me?
Yeah.
Yeah, so I was saying I created a shared folder on Google Drive and I'll upload everything there. I already shared the link for the previous videos.
Okay. So here, just try it out. Like these are very basics, is that, but like I believe the best way to learn anything is to really do it hands-on, so that you are 100% focused. So, and also these are the things. Do let me. These are very basic things, but I think the concepts is important rather than, because at the end of the day, you know what happens is big data infrastructure you can build up. At the end of the day, you write queries. So the more time you spend on actually writing the queries and everything, it's like comes like better. Yeah, it's like you're doing it hands on, and solutions are also there for this. So if you like stuck in any solution or if you want to do it, I did for the sandbox, but everything remains the same. Or like just send me any question on Slack for this. They are very basic things, but it will help you with that. Yeah. So the solution is also there. These are the very like Hive is there, SDFS basic things. This is what Spark is there. I would definitely encourage to work with Hive, Spark, and like Kafka. That way we'll have a better understanding of that, and then probably like we will like summarize some of the designs and how we can do it. All right. Okay. Yeah. All right. Thanks everybody. Thank you. Bye.
Thank you, Himanshu.
So if I stop share here, it's recording, I believe. So it will save on my hard drive. This one, where it will save on your.
Himanshu, can you hear me?
Huh?
Stop recording. No. Stop.
Give the idea for how to create a Zoom for me, like I am meeting and how
It's in
Zoom
confidence.
account.
No, it's in confidence.
Zoom account, do not record any access, do not record any upload.
Hello, can you